The Better Fertiliser Decisions for Cropping interrogator used data from 4,000 trial sites, about 5,000 pieces of information, and those trial sites range from central Queensland down through the eastern states, Tasmania, South Australia, West Australia. So there was a large geographical spread, large change in climate zones as we went through those different geographical zones. There were soil texture changes, moisture holding capacity changes, in-season rainfall, large variations in in-season rainfall, and large variation in temperature towards maturation. So you would expect there would have been large variations in yield, and obviously there were. So how do you make sense of that? 4,000 trials, 5,000 pieces of data. Well, you break it down to the simplest you can, and what they did there, they just took relative yields. And the relative yield is the yield on the plots without any fertiliser at all, in other words the control plots or the untreated plots, over the maximum yield that was achieved in each trial, which, so where the nutrient wasn't limiting, and they looked at that as a percentage. So relative yield is the minimum yield without any fertiliser over the maximum yield where there was where the nutrient wasn't limiting by 100%. So just one piece of data per trial. Now here we have 14 trial sites, 1 to 7, 8 to 14, okay, with soil test values ranging from 3 to 25. So we might think of this as Cobble P. It doesn't state what it is, but let's think of it as Cobble P. Cobble P is ranging from 3 to 25. Then we've got our maximum yields in tonnes per hectare and our minimum yields, our Y maximums and our Y zeros, okay? And we have to work out the relative yield in each case. So to do that, relative yield is Y0 divided by Y maximum multiplied by 100, which in the case of the first one is 2.6 over 2.6 multiplied by 100 is 100, okay? In other words, it was a non-responsive site. The soil test value of 20 was too high to get a response to the fertiliser. Now the next one, trial site 2, 1.4 was the Y0, 1.4 divided by 2.4, the Y maximum, as a percentage, 58%. So a fairly responsive site at let's say a Cobble P of 6. Site 3, Cobble P of 11, Y minimum is 2.6 divided by 3.2, the Y maximum, and that comes to 81%. Okay, and site 4, the lowest recorded value of 3 Cobble P, 1.6 Y0 divided by 4.1 Y maximum, 39%. Okay, so a very responsive site, very responsive, fairly responsive, no response. Okay, so what I'll do now, I'll complete the relative yields for the 14 sites, and then we will look at plotting them in a graph, okay, a calibration curve, which is exactly what has been done in Better Fertiliser Decisions interrogator. So what we have here, we have the data now from these 14 sites, the relative yields, ranging from a low of 39% at a very responsive site, Cobble P of 3, through to 4 trial sites with no yield response at all, and they had Cobble Ps of 20, 22, 25, but surprisingly Cobble P of 9. So we're going to do the same thing now that what the interrogator does. We're going to graph that in a calibration curve and see what sort of a plot we got, just see what the curve is and see what sense we can make of it. Okay, so soil test value 20, relative yield 100. 20, relative yield 100. Soil test value 6, relative yield 58. 6, 58. Soil test value 11, relative yield 81. 11, 81. Soil test value 3, relative yield 39. Okay, and you can start to see that curve developing. Okay, so it looks as if it's going to be a pretty reasonable sort of a curve. So what I'll do now is I'll complete the points of the curve, and we will look at the curve. So that's our last point. So now you can see we've got a fairly good calibration curve which would have quite a good R or R squared value if it wasn't for these two outliers. So there's a couple of outliers here. This one here had a sawtooth value of about 14, and you would have expected it to be up here with the others, okay, in that range, but it's not. So what's happened there? Well, maybe that was a very high PBI site, and 14 just didn't fit in with this calibration curve there compared to the other PBIs, okay? Could be a very high PBI site that needs a much higher critical value. This one here got 100% yield at a very low level, so it could be the opposite. It could be a very low PBI site, or there might have been other stresses on the crop that prevented the crop from you know, reaching its full potential, one or the other. So you get a calibration curve, you'll get a whole lot of dots. For example, if you look up phosphorus for wheat, for 0 to 10 centimetres, you'll get about 1,300 dots, okay? And they will draw the curve, and what they will then do, they will give you the critical value or the critical range at 80% relative yield, 90% relative yield, and 95% relative yield. And if we come in here at 90% relative yield and come across until we hit the curve, you'll see that the critical value, soil test value, is about 15 milligrams per kilogram. Okay, so that's what interrogator does. It gives you a critical value and it gives you a critical range for 80%, 90% and 95% of relative yield.